Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Cakra Andika, a naval architecture student from University of Indonesia. And in this video, I want to explain more about my answer during the final exam in numerical method class. So first, this is the instruction that Mr. Dai want us to do. First, I have to do muhasabah. Muhasabah is a reflection of ourselves during this class. I think my biggest evaluation during this semester, especially during the numerical method class, is how ignorant I am. Sometimes I miss a lot of information, but I still try to my best to catch up with the other. I also have evaluation for my punctuality to submit the assignment. I need to take more time to understand the assignment. And I think last thing that I want to evaluate is sometimes I get distracted during the class. I'm I don't really pay attention during the class, and I really regret it. And if I can rate my uh, effort and work during this class is and also my productivity is I will give myself an 80 out of 100 because even though that I sometimes late to submit my assignment, uh, at least from now I've already made 8 videos for the numerical method class, and I already explained everything that get from the class with my previous videos. Next is intention. Intention is for me actually to set a goal during solving this problem. I want to set my short-term goals and long-term goals. My short-term goal is to solve the problem on the module. This is the module, student version military application of Spring Math System. There are several problems that I will explain more in this video. Uh, and my long-term goal is because I know that this knowledge is very important for me. I believe that this knowledge is come from God, Allah Subhanahu wa Ta'ala. So I will extend this knowledge for kindness to the others and for the future. Okay, next is initial thinking. In initial thinking, I have 4 points to explain. First, identify the problem. Selecting the optimal shock absorber for the STT, and then understand the requirement. The shock absorber must balance cost, reliability, and protective capability. Next is assess the given data by specifications for the three shocks, force modeling on rough terrain, and damping coefficients. And last is formulate the approach by use mathematical modeling in differential equation to evaluate the shock's performance. And now for the idealization, this is from the module itself. Idealization is actually to simplify the problem and then to make it more manageable and then to help us understand more about the problem. First is simplify the suspension system. Model SCT suspension as a single shock system. Two, we use differential equation like on the image. M multiplied by d square x per dt square plus beta dx per dt plus kx equal to ft, where m is the mass of the loaded trailer, beta is the damping coefficient, k is the spring constant, and ft is the external force. And then three point number 3, external force modeling. Consider the function on rough terrain as Ft equal to 200 sin for Tn. And then initial condition assume that initial displacement and velocity are zero, x zero equal to zero, and x accent zero equal to zero. Next is instruction set. First is modeling the system with different shocks. Critically damped value calculation with this formula beta c equal to 2 akar mk. Compare each shock's damping coefficient, the critically damped value. In the first step, also solving the differential equation for each shock. Solve the differential equation with the given damping value and solve again the critically damped value. And then also plot the compare solution. Next is analyzes the recommendation, discuss the performance of each shock, and then decide the best shock based on displacement and damping behavior. And then for the step two is non-homogeneous equation analysis. Solve the non-homogeneous equation by this formula for each shock, and then plot the solutions and find maximum and minimum displacement. Discuss long-term shock performance and recommend the best option. And for the recommended shock, solve the homogeneous equation and identify transient and steady state solution. And then the third step is evaluation of the budget committee's preferred shock is analyze undamped shock K equal to 25 Newton per meter, beta equal to 0 Newton second per meter under variable frequency forcing function or FT uh, equal to 200 sin for omega t, and then solve the initial value problem and determine the significance of omega, discuss the system's behavior at critical frequencies and create interactive plots. And then the fourth step is field testing and data analysis. Use displacement data to estimate the damping coefficient using mathematical method. Evaluate hypothesis resonance orbits, and then assess structural integrity under prolonged use and extreme condition. And then on the other thing, that we can also do additional simulation by model the suspension system over root root terrain using impulse function, solve the initial value problem using Laplace transforms, determine the maximum and minimum displacement, and assess the shock system's performance over rock terrain, provide guidance on operational limits and recommendations for transferring route rough terrain. And then this is for the pseudocode that Mr. Dai want us to do. There are several steps that I use to make this code. Is first define the constant and initial condition, and then there is also another five step like analyze each shock, and then step two is determine the performance on rough terrain. Step three and step four is evaluate the undamped shock proposed by the budget committee, and step four is field testing and data analysis. And then this is the step five is additional simulation for rock terrain. And then for the explanation is define constant and initial define constants and initial condition. Set the mass of the trailer initial conditions and for function. And then for the shock specification is list the available shocks with their spring constants and damping coefficient. Helper function include the function to calculate critical damping, solve differential equation, find extremes, and analyze a solution. And then for the analysis of this code, I will explain step by step. Step one is analyze each shock by solving differential equation with given critical damping value. The compare and plot solution. This is the code for the step one. And for the step two is evaluate the shock performance on rough terrain by solving the non-homogeneous equation, finding displacement, and discussing long-term performance. And it says the code for the step two. And then for the step three is evaluate the undamped shocks proposed by budget committee under variable frequency conditions. And this is how I code for the step three. And then for the step four is analyze field data to estimate damping coefficient, plot data, detect resonance, and assess structural integrity. This is the code for the step four. And the last step is perform additional simulation for rock terrain and solve the initial value problem using Laplace transform and provide operational guidance based on the result. This is the code that I made for this step five. I think that's all for my explanation. I really hope it helps other to understand about the problem in this video. And I also want to thank Mr. Dai because this is such a unforgettable experience to be attending in your class. I think that's all for me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.